There we go. Okay, now we're recording. All right, so this is called the difference quotient. And like I said, three pieces. We want to be able to find f of x plus h, negative f of x, and h, and simplify. So there's a little bit of algebra involved with this. So we're going to work with a simple function. They're going to give you f of x. They're going to tell you what it is. In this case, it's x plus 2. And I'm going to take this and I'm going to evaluate this, for f of x equals x plus 2. So what I have to do is break it down into steps. So the first step is to find f of x plus h. So what that means is everywhere I see an x, I'm going to replace it with x plus h in parentheses. All right. So this x here, she's replacing it with x plus h in parentheses. All right. And that would be f of x plus h. So everywhere I see an x, I replace it with x plus h. So I get f of x plus h instead of x, it's x plus h plus 2. All right, so I cut the x out and I replaced it with x plus h. It's really what you're doing. All right, so, and I don't need the parentheses here because you're just adding, so she simplifies it. It's x plus h plus 2. So that is f of x plus h. That's step 1. Step 2, do negative f of x. I like doing the negative with it. That way you don't forget. The negative changes the sign of everything. So if f of x is x plus 2, negative f of x means I multiply by negative 1. So I'm going to distribute the negative there. So the negative, what it basically does is change all the signs. So this becomes negative x minus 2. All right, so that's negative f of x. And once I have these two things, my third step is to plug it into the difference quotient and simplify it algebraically. So what I'm going to do, I know that f of x plus h, I've simplified it. It's x plus h plus 2. All right, that's your f of x plus h. And then I'm going to do plus negative x. So I'm adding this on top. Right here, and I'm dividing it by h. Okay, now a couple things I'm going to simplify this. The simplification of it, you can't like cross the h's out unless h is the only thing. In this case, it's going to be, cross out the stuff on top first, because you see the x and the negative x cancel, and the 2 and the negative 2 cancel, and you're left with h over h, which is just simply 1. Okay. And that's, so that would be my difference quotient. Most of the time, your difference quotient is going to be a function of x, but here it just came out to be a number. Okay, so we're going to work one. This would be, example 2 would be something like you would see in 1325 and you would have to do. The thing that makes it harder, not terribly hard, is that you have this x squared here. All right, so we're going to step through all the steps one at a time. So first step, find f of x plus h. So that means everywhere I see an x, I replace it with x plus h. So this x gets replaced with x plus h in parentheses, squared plus 3. All right. So that's f of x plus h. The hard thing is now I have to do the algebra. I have to multiply it out and simplify it. And so you need to remember, very, very important, this is the first error they make. It's not x squared plus h squared, right? Because this means x plus h times x plus h, right? So we have to FOIL that out. Okay. Now, so I'm going to FOIL this first. So my first, let's put a 2 there. The first would be x squared. First outsides would be xh. Insides would be xh. And last would be h squared. Okay. So I can simplify this because these are like terms. Xh plus xh is 2xh. We've got 2 of them. Okay. And if I were taking 1325, you're going to be doing x plus h squared a lot. So if it were me, if I were taking 1325, I just memorize that. That's x squared plus 2xh plus h squared. That way you don't have to keep doing it all the time. So if I were taking 1325, I'd probably want to just know that so I didn't have to do all that algebra. So if I multiply everything by 2, now I distribute the 2. I get 2x squared plus 4xh plus 2h squared plus 3. All right. So this is my final x plus h. Okay. Now, step 2, I need negative f of x. Whoa. I guess I came down. There we go. All right, negative f of x. And a negative f of x, you're just changing all the signs of f of x. So it's negative 2x squared minus 3. See, I just changed the signs. The last step is to plug it into the difference quotient and simplify. So I'm going to do f of x plus h minus f of x all over h. So f of x plus h is all of this. That's 2x squared plus 4xh plus 2h squared plus 3. And then minus f of x was negative 2x squared minus 3. And then I'm dividing it by h. Now, what's going to happen? This looks gross, all right, but what you're going to do is a bunch of stuff on the top is going to cancel. In fact, I'm going to tell you everything that doesn't have an h in it should cancel. That's one thing, that's one way to check myself. So like the 2x squared, and that cancels. And 3 and negative 3. See how everything that didn't have an h canceled, all right? The reason that happens is because the top now becomes just 4xh plus 2h squared over h. And I can factor the h out of the top. If I take an h out, I'm left with 4x plus 2h and have an h on the bottom. And those guys cancel. So the h on the bottom should always cancel with an h on the top, all right? If you can't cancel an h, you've done something wrong. The h's always have to cancel. And I end up with 4x plus 2h. Whoa. Okay, so that would be evaluating the difference quotient. That would be my final answer. This will have meaning to you when you get to 1325. It's what they call the derivative. If I take the limit as h goes to 0, it represents the instantaneous rate of change of a function. So that'll have meaning for you when you get to 1325. Not the way that you normally take derivatives, just kind of a, like it starts off with a bang. You start off with this and you get a little scared, but then there's easier ways to take derivatives and you don't usually use this. So, but you use it in the class in the very beginning. So I wanted you to see at least a couple examples of working this. All right. Because you will have to do it in 25. Okay. Any questions over that one? Okay, so she's got a bunch of practice. We're not going to do all of them. We're going to do a few of them. We're going to do number 1 here. You'll notice this one's pretty easy because it's just a line. So step 1, find f of x plus h. So everywhere I see an x, I replace it with x plus h in parentheses. So you see I just replaced the x there with x plus h. Now, this is not subtractive. Don't forget that you're distributing here. So you multiply everything by negative 3 in the parentheses. And there's really nothing else I can do with that. So that's my f of x plus h. Okay. Step 2, negative f of x. So just change the signs. So that would be negative 5 plus 3x. All right. Step 3, plug it into the difference quotient. So f of x plus h is 5 minus 3x minus 3h. Negative f of x is negative 5 plus 3x all over h. Okay. Now everything without an h should cancel on the top. So 5 minus 5, negative 3x, and positive 3x. So I'm left with negative 3h over h. The h's cancel and I get negative 3. All right. So you'll get a number for the difference quotient when you have a line. You'll notice this is just a line and it has a slope of negative 3. So looky there, you'll notice that the difference quotient for lines always comes out to the slope. So that's a quick check for you. When you're working through the difference quotient, you have a line, it should be the slope of the line. It will always come out to that. All right, because that's the rate of change of the line. All right, which is what we call a derivative. All right. So with lines, you can always check them. All right. You okay with that? Okay, now there's a lot of functions they can plug into that difference quotient, but because you're taking business math, it's pretty much going to be a line or a quadratic in x squared. So let's, there's another line there. I know it's going to come out to 5, but we're going to work another problem. Let's work number 3. Okay. So this is a quadratic. So let's see what happens. So step 1, I need to find f of x plus h. So I replace x with x plus h. So it's 3 times x plus h, whole thing squared. All right, so you're going to have to square x plus h a lot. I told you, oh, it'd be really good to memorize it, right? So I'm going to pretend I knew what it was. If you FOIL this out, you're going to get x squared plus 2xh plus h squared. Okay, and I memorized that. If I run 1325, because I keep doing it all the time. All right, so then I need to distribute the -3. So you get minus 3x squared minus 6xh minus 3h squared. So all of this, that's my f of x plus h. Okay, I've got it. We're good there. Step 2. Is that right? Yeah. Let's see, negative f of x. So negative f of x just changes the signs. So here's f of x. So you're going to get -8 plus 3x squared. Now we're ready to plug it into the difference quotient. This one is really thick. That should be better. All right, so now we're going to do the difference quotient is f of x plus h minus f of x over h. All right, so f of x plus h would be the stuff right here. So it's 8 minus 3x squared minus 6xh minus 3h squared. I'm going to do minus f of x, so that's minus 8 plus 3x squared. All over h. Everything without an h should cancel, because see the 8's cancel. I've got 8 minus 8, and I got negative 3x squared and positive 3x squared. All right, so what am I left with? I have negative 6xh minus 3h squared, and I'm dividing it by h. All right, so basically, you can factor the h out of there, but it's going to cancel. So if you want, you can think about it like you're just dividing both of these by h. So I get negative 6x. The h's will cancel here, and h squared over h would be 3h. Okay, and that would be my difference quotient. All right, if that bothers you, factor the h out of the top. And go over here. Like so, right, and then cancel. Okay, all right. Is that okay? Okay, so you're going to be working this in 1325 quite a bit in the beginning, and then after a while, you kind of step away from it. You learn faster ways to take derivatives, but you will have to work with this. All right, so my suggestions to you, things to remember, everything without an h needs to cancel. If it doesn't, you've done something wrong. The h on the bottom should always cancel when you work the difference quotient. It should always cancel. And I do, like I said, I do memorize the x plus h squared, so I don't have to keep doing it over and over again. Okay. All right, so that's your difference quotient. And that's the end of what we're going to do today. It's the end of what we're doing in our class. The 1324 stuff for today is really heading into 1325. It's more look ahead at 1325. So I'm going to jump up to that page. You're going to be graphing functions in piecewise notation. Piecewise notation is used because you're going to get what they call a limit. And the thing with the limits is that I really like this bar. Well, the thing with the limits is it's hard to get one side of limits from a graph. So they do these piecewise functions. That's why they do it. Fortunately for you guys, you're really going to only see lines most of the time. when I was a pre-cal teacher, I used to do like a cut and paste activity with these things. I still wish I could do it. Because really what it is a cut and paste. All right, so the way that piecewise functions work, I'm going to zoom out a little bit so you can see all this in one page. Well, that'll be good. All right, so it's like a cut and paste. It's made up of different parts. So like you split it, like maybe the left side of the graph looks like some graph and the right side of the graph looks like a different graph, okay? Or maybe there could be more pieces than that. But it's basically a function that's defined over 2 or more intervals. You could have 2 pieces, you could have 3 pieces, whatever, okay? It may or may not be continuous. It just depends on what the graph looks like. So a piecewise function is kind of defined like this, something like this. All right, it's got one parenthesis, it says f of x equals. Now what it's saying, it equals 2x plus 14 if x is less than or equal to -3. So for all values of x less than -3, it looks like 2x plus 14. If x is greater than -3, it's going to look like that. That should be an x there, 16 minus 2x. Okay. So this is what it's telling you is basically at -3, things change. All right. So the first thing you want to do is look at that divider. So where these things split is where the graph is going to change. So one of the best things you can do is draw a vertical line at -3. That vertical line doesn't really exist, but it's just to remind yourself you can't cross it. You know, you can touch it with a dot, but you can't cross it. All right. All right, so how to graph this. I'm going to do this a little differently than she does. I don't like the erase stuff. So if x is less than -3, what I basically do is I recognize that there are 2 functions there. And they're lines. All you need are 2 points. I'm going to make a little table. I just need 2 points. So I want to start at the boundary. The boundary is -3. So I'm going to start at -3. And I'm just going to plug it into the 2x plus 14. So I get like -6. I'm going to get 8 when I plug it in. I just plugged it into there. I get -6 plus 14. Now, this is true for any value less than -3. So I'm just going to get another point. It's just a line, right? It has a slope of 2 and y-intercept of 14. I'm just going to get another point. So I like anything less than -3 is allowed. I like -5. All right, it's just an arbitrary thing. I have to pick a point less than -3. So 2 times -5 is -10. And if I add 14, I'm going to get 4. All right. So 2 points are enough to define the graph of the line. So my first point, I should mention, if you have an equal on the boundary, use a closed dot. If you don't, use an open dot. All right. So for -3, for this piece that I just graphed, it does have an equal. So I'm going to use a closed dot at -3. All right, so -3, 8, I'm going to graph that point. Right there with a closed dot. And then I'm going to graph another point on the line, -5, 4. -5's here. There's another point on the line. It's just a line. So you connect the dots, and that's the equation of your line. And but I can't cross the boundary. I'm going to start at the boundary, and I'm going down. That was supposed to cross the dot. Here we go. That's better. All right, so I drew the first piece. All right, but you'll notice how -3, that thing, it's cut off, it stops. For x greater than -3, it looks like this. All right, so I'm going to make another table. I only need 2 points. All right, so I'm going to start this at the boundary, which is -3. And I'm going to go above -3 so I can pick any point bigger than -3. All right, I happen to like 5. All right, this graph wasn't the best graph to use because it goes up off the graph. Because if I plug in -3 here, I get 16 minus 2 times -3 is going to be +6. I end up with 22, which is unfortunate because it's off the graph. And if I plug in 5, 16 minus 5, that's 16 minus 10, that's going to be 6. All right, so I can't really graph this point, but if I could, it'd be all the way up here, right? All right, here's 22. All right, Now I'm going to use an open circle because there's no equals on the inequality, so I'm not including that point. I'm just making it an open circle on the boundary. Oh, that's not the boundary line. On the boundary line, which is -3. So I would have to plot the point -322, but like I said, not the best of choices, just because it's off the graph. But we'll pretend we could get there. Oh yeah, let's say 22 is all the way up here. All right, so I plotted -322. The other point is 5, 6. 6. And obviously I can just connect the dots and we go forever. And I don't cross that boundary line, right? Pretend you never cross that boundary line. Okay. The one thing you never want to see with piecewise functions, you should never see like one graph and another graph on top of it. You should never see that. All right. It should always look like one graph and then another graph, right? But you should never see the two be like top to bottom lined up, okay? Because otherwise it's not a function. All right. So so you just have to remember stop right at that boundary. All right. Any questions about that? I'm going to go down a little bit. All right, so to find the domain and the range of piecewise graphs, my suggestion would be wait till you graph it. When you graph out, it's a lot easier to look at a graph than it is to look at these equations. So the first thing you want to do is graph them. Remember, domain is X and range is Y, and we'll talk more about that. All right, so this first graph, you'll notice it has 3 pieces. It's got 1, 2, 3. That's okay. That can happen. You can have 3 pieces. You can have an infinite number of pieces, but so there's 1 piece for x less than 1, there's 1 piece for x equals 1, and there's 1 piece for x greater than 1. So 1 is my boundary. I'm going to draw a vertical line there. Remember, I'm not going to cross it. Okay, I think I'm going to start with this piece because this piece is super easy. So this just tells me it's when x is 1, y is 3. That's just a point. So when x is 1, y is 3. That's that piece right there. Just a closed dot at 1. All right. So the other piece. This is not a line anymore. It's a parabola. So I should see something like a parabola. Just to remind you, like x squared might look like this. And for x less than 1, what happens is I'm going to stop at 1. So wherever x equals 1 is, I'm just going to erase that part of the graph, and I should see something that looks like that. Okay. So we're gonna do some points. I'm just gonna make a table for this first piece. All right, the thing to keep in mind, x is less than 1, so start at 1 and go backwards. It's probably fine. Okay, so I just pick values of x, and I'm gonna plot them. Okay, so y is x squared. So 1 squared is 1, 0 squared is 0. -1 times -1 is 1. And -2 squared is 4. All right, so those are just points I'm going to plot. Now let's talk about the point here. Because it doesn't have an equal, I'm going to use an open dot. All right, so open dot at the boundary at 1, 1. So 1, 1, open dot. Then I have other points to graph: 0, 0, -1, 1, -2, 4. That's plenty. All right, but you can see that that parabola is coming out now, right? Just graph, connect the points, and there we go. Okay, so I've just graphed the first piece. All right, so the second piece was just a point when x is 1, y is 3. See how that closed dot fills in the open dot? You should never see 2 closed dots lined up on top of each other. Okay, so then we'll do the third piece. The third piece is 6 minus x. And see, there's no equality here, so we're going to use an open dot for x greater than 1. So we're going to start at 1. It's just a line, so you really only need 2 points. I like 1 and 4. It doesn't really matter. So if I plug 1 in there, 6 minus 1 is 5. Plug 4 in there, 6 minus 4 is 2. All right, so 1, 5. Again, I'm going to use an open dot because there's no equals at the boundary. And 4, 2. All right, and I know that that's a straight line, the slope of -1. So that just goes down something like that. So I've just graphed a piecewise function. All right, I want you to see that, you know, if I were to run a vertical line across this, let's see if I can do it. Let's see. Where's my line thingy? Draw. Well, maybe it's not going to let me. If I were going to run a vertical line all the way across this, I can't do it. It only crosses in one place. See, even with these circles right here, there's 2 open circles, 1 closed circle. So, you know, there's only going to be 1 point for all the values of x because they're functions. All right. So now the domain is actually quite easy. Once you have the graph, you can look at that, see that this goes all the way to the left, right? This piece does. And this piece goes all the way to the right. It goes down for up forever. So the domain is all real numbers. So we say that negative infinity to infinity. All right, now to get the range, well, let's kind of do it this way. Let's see it this way. To get the range, you can see that y goes all the way up. So it goes to infinity and it goes down to 0, but you see this piece picks up and this goes down to negative infinity. So again, the range is all real numbers. Okay, let's do this. Oops, sorry, that wasn't my best bracket. All right, so for this piece, but you pretty much I can get it from looking at the graph, the domain and the range, so I don't have to worry about that too much once I have the graph. All right, are we okay with that? All right, everybody good? Yeah.
Yes, ma'am.
All right, so we got one more. This particular graph has 3 pieces to it. Not sure why that happened. Hold on a second. I'm just gonna get rid of this thing. I can't. Interesting. Can I annotate? Let me clear this out. Yeah, I did. There we go. I want to draw with this thing. Where's that? There, and we get a different color up. Oh, let's do. All right, so this particular graph, it has 3 pieces. It has 1 piece for x less than -2, 1 piece for x between -2 and 2, and 1 piece for x greater than 2. So you have 2 boundaries. You have -2 and 2. So I'm going to draw vertical lines there that I know that I'm not going to cross those boundaries. All right, those vertical lines aren't part of the graph. They're just telling me not to cross. Okay, so what this does is, one thing you'll see, this graph basically has 3 pieces. It has a piece to the left, it has a piece in the middle here, and it has a piece to the right. All right, so there's 3 different pieces to it. So we're going to graph each one of these pieces separately. So I really want a different color pen. All right, so my first piece is a line. So it should look like a line. So let me make a table. For line, I only need two points is good enough. X, -2x minus 1. All right. And this line is valid for x less than or equal to -2. So I'm going to start at -2 and I'm going to go down. I only need another point, so I'll do -4. All right. And then I'm going to remember that when I plot the point at -2, because there's an equal, I'm going to use a closed circle because of the equal. All right, so -2, if I plug that in, I get 4. I'm going to get 3 here. Close circle at the boundary. I plug in -4, 2 times, that's going to be 8. I'm going to get 7. All right, so I'm going to plot those 2 points, and that'll be my first piece. All right, so -2, 3 is right here, close circle, and -4, 7 is right there. Connect the dots, can't cross the boundary, just keep going the other way. It goes that way. All right, so that's my first piece. All right, my second piece. Now this has two boundaries. So I need to go from -2 to 2. -2 does not have an equal, so this guy's going to have an open circle. This one does have an equal, so it's going to have a closed circle. Now, because it's a quadratic, I probably need a couple more points, so I'll just do I'll just go up by ones, right? So I can fill those in. All right, and I'm doing x² - 6. All right, so if I plug in -2, that's going to be 4. I'm going to get -2. If I plug in -1, -5. Plug in 0 - 6 is -6. 1 - 6 is -5. And this guy's going to be -2. All right, so I'm just going to plot those points. All right, -2 to -2 is an open circle because of that no equals. I'll wrote it right there. -1, -1, 2, 3, 4, 5. 0, -6. 1, -5. 2, -2 is going to have a closed circle. All right. So there's that guy. Okay, and then what do I got left? Oh, I got another piece. Right, I gotta do this guy. All right. So again, that's just a line. This is an easy piece. This is true for x greater than 2, so I'm going to start at 2 and go up. I only need like 2 points. But I'm going to pick, it's not the best graph for this, but it's there. All right, so if I start at 2, I look at your boundary, there's no equal, so you're going to use an open circle. All right, so 3 times 2 is 6, plus 4 is 10. You'll see we're going to go off the graph here in a minute, which I don't like that, but 3 times 3 is 9, plus 4 is 13. Okay, so it's just a line. All right, so first I'm going to plot 210, which is all the way up here. Then open circle, and then I got to go to 313. So 10, 11, 12, 13. 313 is like right here. All right, and I'm going to connect those dots. Don't cross the boundary. All right, it's a straight line that goes up. All right, so what I've done, I've just graphed it. Okay, you can see I got one piece to the left, one piece to the middle, one piece to the right. The domain of this, pretty much if you look at this, it's all real numbers because it covers everything. It covers all numbers less than -2, between -2 and 2, and bigger than 2. So you see that every single x value is covered. The domain is all reals. Now the range is the tougher thing. It's kind of a weird range. So I'm gonna kind of, what I like to do when it's really complicated, you want to look at the graph and you want to see, well, for what y values is this thing? Oh, don't do that. Sorry, let me change it back. Hello. Attack. Oh shoot, sorry. I'll come back to that. Let me go back to where I was. There we go, I'm back. Let me get the pen to a different color. Oh, that's fine. Sorry, I messed up. Change color, let's go back to blue. And the thing just won't do that for me. Hold on. Try selecting it and changing it. Select it. No, that's not what I want. Come on. There we go. No, there we go. See if it'll let me change color. There we go. All right, so it's back. All right, so with the range, I wanted to do this in yellow, but obviously it's not going to let me. So what we're going to do is, if you look at this, the y, it doesn't go all the way down. It kind of goes down to here, and it goes up to -2. So that this right here would be part of my range. And when you have a closed circle and an open circle, closed circles win. So I know it goes from -6 to 2. And then there's this gap. So I don't want to include that in my range. And then I see the graph picks up over here, and then it goes up forever, right? And so that would be my range. So what I have is I have to exclude this little gap here. So what I'm going to do is say, all right, I know it goes from -6 to -2. That would be my first piece. Because there's closed circles there. There's square brackets. Then I'm going to put a union, and I'm going to put this other interval. So the other interval goes from, looks like 3 all the way up. So it goes from 3 to infinity. Infinity is always round, and because of the closed circle, 3 is going to be a square bracket. So that would be my range. Okay. So you're always you're looking at the graphs to get the domain and range. All right. So that's when you take 1325, those of you that are, these are the things that you're going to start off with. Okay. So, and I think, is that it? Let me check. Yeah, that's pretty much it. Yeah. Okay. That's it. So, in terms of the final, there's no piecewise on there. You won't see that on there. There is a log, like convert an exponent to a log and a log to an exponent. So you will see that on the final. Pretty much for your final, it's all the second part of this packet other than the exponent to logs. That was the one thing I saw. Should be able to use your calculator. Exponents, there's exponent simplification problems on there. Don't forget there's a difference between this. If I had 2x to the -3 versus 2x to the -3 in parentheses, right? Those two things are different. Right, with the first one, the only thing that's being taken to the -3 is the thing right before it. So it's 2 over x cubed, whereas something like this, it's 1 over the whole thing, right, cubed. So if I cube the 2, I get 8, so it's 1 over 8x cubed. So just keep that in mind. Anything to the 0 to 1. So you should know your exponent rules and be able to work with exponents comfortably. Negative exponents, you should be able to turn those into positive exponents. All right, so that's some things I saw in the final. You should be able to solve a linear equation, something pretty basic, something like those. If you have fractions, remember to multiply by the common denominator. That way you can get rid of the fractions. Let's see, and then like converting radicals to fractional exponents. Remember this rule here, right? That the index goes on the bottom and the power goes on the top, right? So those are things you should know. You should be able to write an inequality, graph it, and do the interval notation for it. Right? Interval notation. So you should be able to write these in something like these in interval notation. Tell where a function's increasing, decreasing. Should be able to multiply two things together. Big thing we did was factoring, right? Take out the greatest common factor, and then we had factoring. I want to do that. Factoring 3 terms. I did kill the common factor with you guys. Should be able to factor and solve by factoring. Difference of squares. You should be able to take the square roots, right, and factor that. You should be able to solve them. Let's see. Factoring. It's a lot of time spent on factoring. 4-2, you won't see anything terribly complicated, so you can ignore 4-2. That was more 1325 prep. Should be able to solve by factoring, set each factor to 0. A quadratic inequality, yeah, there was one of those on there. I think I showed you guys a shortcut with a calculator on that one. Quadratic equation you will not see on the final. Not to worry about it. You should be able to simplify, like by canceling expressions, right? Factoring, cancel, simplify rational expressions. Should be able to solve rational equations, something maybe like number 1 here. Remember, if you're not good with the algebra there, you can also just use your calculator, right? Your calculator, you plug the left-hand side in Y1, the right-hand side in Y2, and find the intersection. So don't be afraid to use the calculator to solve equations, especially if you struggle with these kinds of things. Finding an intersection is pretty much the same thing. You just solve for y, plug them in the calculator, and find the intersection. I wouldn't solve these by hand. You know, I would just use the calculator. Let's see, we did those. Function notation should be pretty comfortable with something like, you know, if I gave you f of x, you know, was 2x plus 5, find f of 4. I mean, you know, just plug in x is 4. Logs, the only thing from logs I saw was like converting a log to an exponential to a log, you know, like for example, it's not even in this section, but if you, like, if I wanted to write log, let's see, whoops, log base, if I told you log base 6 of x equals 3 in exponential form, remember you keep the base and you switch x and y, so 6 cubed would be x, right? That was the way to convert back and forth. If I had something like 2 to the x equals 5, if you write it as a log, remember you go log, keep the base, so it's log base 2, and switch these guys of 5 equals x, right? So keep the base, switch x and y. So I saw something on there about that. The difference quotient you will not see. It's just getting you ready for 1325, okay? All right, so I think the final's pretty easy. I put up a practice final. I think I showed that to you. It's on, if you go under final exam items, it's right there. There's a link for it. You can take the practice final as many times as you want. It's not graded, it's just there for you to study. If you can do the practice final, final's a piece of cake, all right? The final will open December 9th, then it'll close December 10th at midnight. You can have a calculator, scratch paper, just strip up the scratch paper at the end to keep people happy.
How many questions on it?
Huh?
How many questions?
20 questions, you have 135 minutes for it. So you've got a world of time. All right. It's not, I think it's pretty easy for a final, but you should study for it. But I think it's easy. Okay. What I want to say, this week we're just doing 10-4, 10-5 and the quiz, right? Over 10-1 through 10-5. Okay. And you get 2 tries in your quiz. So that shouldn't be a problem. Make sure you guys, if you're behind on the homework, some of you are, make sure you get those in, because you can still do those for 70s and you don't want zeros sitting in your grade, right? So if you're behind on anything, get it done. You can still take the quizzes late for 70s. So whatever you're missing, you get done, right? All right, and I think that's pretty much it. Any questions about anything? And the final will be through honor lock, right? It'll open up on the 9th and just take it through honor lock as usual, like you do your tests, okay? It's multiple choice. All right. Any questions about anything?
Professor, I'm sorry I joined a little late. I will go back and watch the video though.
Okay, that's fine.
But I am here.
Okay, that's fine. I saw you. I'll put a link up there in a little bit once I can download it. Okay. All right. Any other questions about anything? So you guys know the final December 9th and 10th, right? Don't forget about it. Okay, because I won't see you. This is our last class. I enjoyed having you all. Good luck on all your finals, and we're done.
Thank you for everything, Professor.
No problem. Take care. We're done. All right. All right. Any questions from anybody that's left? Okay, I'm ending it.